let's talk about the cross product of vectors. Now this is going to be in 3 dimensions. So let's suppose we have 2 vectors. So say your vector V is given as component A, B, C. And another vector, let's say U, has component D, E, and F. So if you want to do U cross V, that's how you denote them. So this is the symbol that we're going to be using to denote the cross product. And this is going to be defined as this determinant of this 3 by 3 matrix. So your first row of this matrix will be our standard unit vectors. You have the I hat, the J hat, and the K hat. Then the second row of this vector will be the component of this vector, since you're doing U cross V. So the components for the vector U is D, E, F. And now for the next row, this row right here, the third row, we're going to put the components of this vector, V. So that will be our component A, B, C. So that's how you set up the determinant of this 3 by 3 matrix. And eventually what you're going to get is a vector. Now that vector is going to be very special because that particular vector will be orthogonal to both U and V, meaning perpendicular. Now let's see how do we compute this determinant. So pretty much here's how you're going to compute this. So for the ith entry, so we have the ith times the determinant of this 2 by 2 matrix. So this will be this matrix right here. So you'll have E, F, and B, C. So you set up a 2 by 2 matrix for the first entry. Now for the second entry, that's going to be the jth, and this will give you minus the entry from the j component. So this will give us the determinant of the following 2 by 2 matrix. So you cross out this and cross out that. This will give you the 2 by 2 matrix. So you will have the entries D, F, A, C. And for the last one, we're going to write down our kth component. So for this one, again, we reduce this to a 2 by 2 matrix. So for the kth component, again, think of crossing this out and crossing that out. You get a 2 by 2 matrix. Find the determinant of that. So you'll have D, E, and A, B. Of course, all of these are numbers. So I'm just writing it in more general form so that you can see how this is computed. So this will give us a vector. Now, how do you find the determinant of this 2 by 2 matrix? So pretty much what you want to do is do the following. So this will give us, you multiply this times that minus this times that. That's how you find a determinant of a 2 by 2 matrix. So we will have E times C minus B times F times the ith components. You'll get a number for the ith component minus, now for this one, again, we do the same thing. This times that minus this times that. So that would give us the number D times C minus A times F for the jth component. Plus, similarly, for the kth component, you'll get D times B minus E times A times the kth component. This will give us the vector. Now let's see how we can perform this with an actual vector U and V. Here we're given 2 vectors U and V, and we're going to find the vector U cross V. So U, you can also write it component-wise. For example, you can write this as 2, 3, 0, since K is not here. And for the vector V, its component will be -1, 1, and 0. So there you have it. And now we're going to perform U cross V. So we set up the 3 by 3 matrix. We're going to find the determinant of this matrix. So we have our I here, J here, and K. Then the second row, we're going to put the component of vector U. So we have 2, 3, 0. And for the last one, components of V, so that's -1, 1, and 0. So let's go ahead and find this. So we know we're going to get a number for the ith component minus a number for the jth component plus a number for the kth component. So that's how you set this up. Now let's go ahead and find that. So we're going to cross out this row and this column. So we have 3 times 0 minus 1 times 0. So that will give us 0. Now for the second determinant of the 2 by 2. So for that one, we're going to cross out the jth row and the column. So you have, again, this times that and this times that. So that's how you're going to multiply these 2 by 2 matrices. So we have 2 times 0 times negative 1 times 0. That'll give us 0. And for the kth component, we again set up another 2 by 2 matrix, find its determinant to cross these out, rows and columns. So you'll have 2 times 1 and then minus 3 times negative 1. So that'll be 2 minus negative 3, which will turn out positive 3. So eventually you'll get to this value for this particular vertex vectors. So you'll have 0 times the ith component minus 0 times the jth component plus 5 times the kth component. In other words, this vector u cross v happens to be the vector with component 0, 0, 5. So that's the vector we obtain when we do u cross v. Now, if you switch the order, something that you want to be mindful of, if you do v cross u, then the only difference is that this is going to be negative of the vector u cross v. So something to be mindful of when you're performing the cross product. So just go over the properties of cross product on your own. And also remember that this vector that you obtain by doing the cross product is orthogonal to both u and v.